Hi, this is Łukasz. Good to have you back. It's been a busy year for EdgeDB. It's now in its beta stage, ready for early adoption. You're watching the 6th episode of Import AsyncIO, an introduction to the Python framework enabling asynchronous, single-threaded, concurrent code using coroutines. This series is intended as a beginner's course, so if you haven't used AsyncIO yet, that's perfect. Just start at episode 1 if you haven't seen that one yet. Today's plan is to introduce you to Starlette and EdgeDB, building a basic web application from scratch. Quite a ride for a single episode, so I hope you have your beverage of choice nearby. It will be pretty hands-on. So here's the plan. We'll be building an application from scratch so you can see each step of the way. The only thing we won't be covering is HTML and CSS, as that's off topic for this series. What is very much on topic though is demonstrating real-world concurrency. This is what we will be after. The idea is to build a microblog that supports text and images, as well as tagging for content classification. I'll be calling it commonplace, like commonplace notebooks people used to carry with them in early modern Europe. There's a rather charming article on those on Wikipedia. With the power of Python, you could extend this later to automatically classify your posts, find similar posts for you and link them, and so on and so on. In fact, all the code that I'm showing right now is on my GitHub, so don't worry about just retyping it while you're watching the video. You can just check it out and, just kind of figure it out for yourself. Now we're going to be actually going through the motions of creating the project, so you can just focus on trying to understand what's going on. Let's first start with our environment. If you watched the previous episodes, you probably noticed some upgrades. And yes, in fact, I am using Fish now, and I have a very, very gorgeous prompt courtesy of Starship. And I'm using VF now for the management of virtual environments. I used to use Virtual Env Wrapper. Now I'm using VF, which stands for Virtual Fish, because that integrates better with that shell. But I'm still using Poetry, so that is actually organizing our project for us. It created a very nice stub of the project that we are going to be filling out right now. Let's add some developer efficiency dependencies first. They shouldn't be a surprise for you. We're going to be adding some auto formatting, type checking, and some useful Flake 8 plugins. So that doesn't really take too long. The dependency resolver in Poetry is pretty performant. And soon after, we're going to be seeing all the dependencies not only added to our TOML file, but also installed. Speaking of the TOML file, if you haven't seen PyProject TOML yet, those organize your projects kind of very neatly. I kind of like how that particular piece of technology is developing, so pretty much a fan of that. So far, it's not very interesting in our project. It only has our dev dependencies. In the production dependencies, you probably have noticed Python 3.9. If you're still on 3.8, you might not be able to run some of the things that I'm going to be showing today, so highly recommend to upgrade. Now it's time for dependencies that actually make this project tick. So Starlette, the low-level ASGI framework, UVcorn, a fantastic ASGI server, EdgeDB, the official database client, Jinja 2 for HTML templates, and Python dateutil for some date munging convenience. So having that installed, it's also going to take us a while. You probably noticed that UVcorn actually was installed with this square brackets standard extra. This is so that it installs with UVloop. Having that makes it much more performant. And this is where the name actually comes from. So at this point, we are ready to roll. We'll be using Visual Studio Code for editing. Before we begin, let me show you around. So all this configuration here is to show you that we're going to be having PyTest configured. We have Flake 8 and MyPy enabled. we in fact exclude some files from being displayed in the Explorer on the left, so that, you know, we don't have our list cluttered. We ignore in gitignore.env files. We're going to talk about those in a while. We're using the standard .editor config file to tell it that we always want to trim trailing white space and end files with new lines. Flake 8 is only here to essentially, you know, not bother us with invalid warnings. Everything else is pretty much standard Flake 8 configuration as is. So let's create the minimal Starlette application right now. So the file starts rather humbly. We are importing annotations from Future that enables forward reference support in them. I recommend to use them actually everywhere, supported since Python 3.7. We're doing some imports right now. Those sometimes work automatically for me with Visual Studio Code, but not consistently, so I actually avoided this particular feature of Visual Studio Code for this particular video. We'll see in the next version, maybe it's going to be improved. We created a Starlette object, called it app, and now using that object we create a route. That route is an async function. We call it error, and in fact it's only gonna raise an exception. We're going for runtime error, saying oh no. That's it for now. That's the start of the project. When Black formatted it, it added an extra empty line. Okay, we can breathe now. It's awesome. Okay, thanks to specifying request and response annotations, MyPy and Pylons now can help us with the API inside those functions, and can also type check the bodies of the functions, so it'll help us catch errors. And we as users have an easier understanding of what to expect. In this particular scenario, nothing interesting is happening. The request argument is not used, and there is no response returned. Instead, we only raise an exception. But this is setting a good precedent for the future endpoints that we're gonna implement. The most important thing here, though, is the app name on line 7. This is now a Starlette application, which itself is an ASGI application. This can be used to serve our own end user code using UVcorn. As you can see, the app variable exists in the app.py module, which itself exists in the commonplace package. So let's run it then. We just need to tell UVcorn where the ASGI application object lives. So we give it the full path, and I'm also adding the -- reload here, so we don't have to restart our application every time there is a file change in our project. So all of that running, we can now point our browser at the endpoint, and as we can see, now we see nice, formatted tracebacks for what went wrong. That shows exactly where the exception was raised in our code. That is very helpful in debugging. On the command line side, we will see that same error, in fact. We see exception in ASGI application, and after scrolling forward, we see our familiar "oh no" message. So I'm saying ASGI this, ASGI that. So what's ASGI? It stands for the Asynchronous Server Gateway Interface. It's an API that provides compatibility between web servers, frameworks, and user applications. It's very low level. In fact, it only contains this one asynchronous function. It takes a scope, which is a dict containing details about the specific connection. It send asynchronous callable that lets the application send event messages to the client, and receive, that's in the middle, an asynchronous callable which lets the application receive event messages from the client. So there can be multiple incoming and outgoing events for each application, as well as background coroutines doing other work like maintaining database connections. Each event is another dictionary with a type key and other type specific keys. This would be painful to program in, So Starlette provides us with a higher level base to base our program on. So let's return to that safer space. In the error endpoint, we haven't really returned the expected response. So let's do that in another one. How about a 404 handler? We can just control space and select appropriate methods on the app, since Pylons and MyPy understand what type we are using. Same with the return value, since we're giving it a response object. So it's actually already helping us to build applications. And did you notice how I keep just typing ugly code, and when saving, suddenly it becomes nice? Well, that's the auto-formatter doing its job. That's the reason we do automation, to speed us up. On the browser side, this gives the expected but maybe a little bland result, not found. We wouldn't want to put HTML directly in our code. String literals are nice, but that would be very clumsy to program in. So instead, let's put HTML in Jinja 2 templates. I already created some templates for us, so we don't have to waste time on HTML now. I'm using Bootstrap for simplicity and Jinja 2 for actual templating, so you can already recognize some variables that we have, as well as a block to fill in. Oh, here it is on line 46. And indeed, in 404 HTML, we extend this base template and put some simplistic content in the body. So now let's write the code to make Starlette aware of this. What we want to do is replace our basic response object with a templated version. Fortunately, Starlette comes with Jinja 2 templates built in. You need to specify where to load templates from. So we specify this using current dir templates. Let's specify what that is next. We're going to be using pathlib for that. I am a big fan of pathlib. It makes path handling much less magical and read much more natural. So we're going to be using that. And now we only need to import Jinja 2 templates themselves. So they live in templating. All right. Looks like this is it. So having all this, we can now actually switch to replace our response with the templated response in the 404 handler. The fun part begins. We're getting rid of that code and just selecting a template that we want to render. So we're saying template response, and we need to give it the name, which in our case is 404 HTML. You already see it in the Explorer on the left-hand side, and give it some context, right? So some variables that the templates will be using themselves. So we're giving it the request, which the header is using for some things. I set it to my own domain just so that there is some domain for links that have to be qualified, and the title of the page, which is 404. Status code, usually we don't have to fill that up because it's 200, but since we are doing an actual exception handler, we want to set the status code to 404. So now that looks much better. But wait, there's still something wrong here. There's a failing image next to the page title. Of course, we haven't configured static files yet, so we're going to be doing this next. Static file support is also built into Starlette. We need to configure it similarly to the templates. Let me do the import first this time. So we're going to be mounting static files as a sub-application of the Starlette app. So we're mounting it under the -static URL, and just specifying the directory under which you can find static files. We actually have some ordering issue here, so let me fix that fast. Boom. Okay, now the current directory can be actually used by both use cases. All right, So having this, we actually don't have to write any endpoint code because we already instructed the Starlette application that for /static /static URLs, this is going to be handled by an application that is already written for us. So with static files in place, we can easily add support for a favicon as well. So let's do a redirect to just see how redirects work in Starlette. So favicon.ico is the typical URL that browsers try out. And for us, what we're going to be doing is to actually tell it, hey, look for that resource somewhere else. So we're giving it the redirect response and telling it to find it in the static files that we now connected using the static files ASGI app. It is in fact an ASGI app as well. All right, so having this, we just import the redirect response and we are ready to roll. Let's see if that worked. Looks much better. And the favicon actually works as well. You cannot see that now in Safari, but you have to trust me on this one. But the error page itself is still showing us the traceback. Oh, that's because we need to add a 500 exception handler as well. So let's just copy over what we already have for 404, since it's already there, a few easy replacements of one number to another, and we should be good to go. So here it is, the exception handler, the template name as well, and the last one is, oh no, the title, and the last one will be the status code. Okay, so that's cool. We saved the file. That there's red squiggly lines that actually we are using that same function name that we already did, because I forgot to rename the function. So I did it just now, no more squiggly lines, and we are good to go. Let's check if now the 500 page looks any different. Actually, it doesn't. This is because Starlette was configured with debug equals true in the code base. That's right there on line 13. We could extract this to a global variable just to move it somewhere else so that we can somehow configure it. But what exactly does that give us? Now it's in line 12, but that doesn't help us much. So fortunately, Starlette has a nice built-in way to deal with this, which is called a config object. It allows us to read configuration from environment variables. So let's configure that object here, specifying some directory right there. And now instead of a value for debug, we're just saying where that value should be taken from and what type it should be cast to and what the default is. So in our particular case, the default for debug is false. It is being kept under commonplace _ debug environment variable, and it's a Boolean, nothing very fancy. So if we restart the server, we will now see different behavior because the default is debug equals false. So that looks nice. However, the server still logs the exception on the server side, so we actually can debug it on our end, but the user sees a nice template instead. So that's the that was the server side. But if we restart the server now with debug equals 1, we will see that same diagnostic page on the browser end as well. So environment variables are great for configuration if you are already in some cloud environment like Kubernetes or AWS, but they sure do annoy us quickly during development. So this is why the config object asked us for a path. It asked us for a path to a .env file. So let's give it exactly that. If we restart our web server with a .env file existing, and that is a file which just keeps a bunch of pseudo environment variables, the server will now treat those as if we gave it as true environment variables. So now, saying debug equals true here will work the same even if we don't pass those environment variables actually on the shell side. So with all this boilerplate out of the way, what is it that we're building? How do we want it to look? We want it to look at something like this. It's just a microblogging site, you know. So when we look at it, what do we see? We see text notes with content and plenty of tags that are published at some date. We can imagine they are accessible under some unique name that's part of the site URL. We'd also like to support images, of course. So given all those, let's talk about databases for a second. We're beginning our story in the 70s after Edgar F. Codd published his paper on the relational data model. A revolution. Data searched by content, not by pointers. What we're trying to see on this timeline is how the story of static data models or schemas versus dynamic data models or schema-less data stores unfolded. Since the very beginning here, we can see that there were two opposing outlooks on data persistence. Rich schema like in Oracle or Postgres versus key value stores like Berkeley DB. Some ran on expensive servers, some were designed for embedding within other applications, or in fact were desktop applications themselves. It's amazing to see that most of the technology that the world runs on today is 20 years old, and the NoSQL trend, understood as hierarchical document storage, is as old as ZODB from the late 90s, with its rich object orientation and tight Python integration. But you'll see another trend in this moment of history: the emergence of object relational mappers. By that time, it became clear that there's an impedance mismatch between SQL data stores and object-oriented programming languages. This was especially true for statically typed languages like Java, but Python has seen some difficulties as well, and SQL Alchemy is, to this day, the most advanced ORM in the entire industry. But we've also seen emergence of schemaless database servers, from horizontally scaling key value stores like Amazon's DynamoDB, through Redis, which started as a remote dictionary server and evolved into a more generic data structure store, all the way to schemaless JSON document stores like CouchDB and later MongoDB. You might have the impression that the world is now in the honeymoon phase with dynamic schemas and easy NoSQL querying capabilities, but there's already signs of fatigue over overly loosely typed datasets, inability to perform advanced queries, worse consistency, instability due to dirty datasets caused by a lack of rigid schema. All those sound like problems that we are now facing with, heavy machine learning trying to sift through the dirty data to actually find any means of consistency there. So what to do? Going back to the classical relational databases seems like a step back in usability and flexibility. So EdgeDB is one of the projects addressing this problem. It's an advanced relational database built on top of Postgres, which aims to change the game in terms of data layer usability as well as performance. It combines an object-oriented data model with a custom query language which is based on set logic, whose explicit goal is to address shortcomings of SQL. EdgeDB makes complex data schemas easy to express, populate, and query. We're actually going to see this in practice, so let's just copy and paste what we're seeing here on the page and try it out. This installs the command line client, and that command line client, being a self-contained Rust binary, allows us to connect to EdgeDB servers, but also to manage EdgeDB server installations. So here we are in fact using that to install an EdgeDB server on my personal box. So having this, we also can now query that server, we can upgrade it, we can actually upgrade the CLI itself. Having a self-contained Rust binary is a very convenient thing for this purpose. A single server version can be used for many projects, so we are creating now a particular instance that is specific to our current project. So this allows us to upgrade database versions per project as well, independently of the data stored inside. So meaning if you have many projects, some can stay on an old version while others can be developed on a new one. Additionally, it automatically generates good credentials for us, so we can connect to the database simply by specifying the name of the instance. No complicated data source names needed. So we already see select one, the simplest query ever, already hit the database and came back to us. So that connection is already working, that server is already running. So now that the server is waiting for our queries, we can return to coding and think about our data model. Let's define a single type for now. We are using a syntax that EdgeDB provides for this purpose, a module that is gonna have a single type for now, a user with a required property, its name. And that name is simply a string. Having that already in the conventional DB schema directory allows our EdgeDB tool to find it. And now we can create a migration for it. EdgeDB comes with built-in schema migration, so we only need to answer a few questions to confirm that the schema changes in the ESDL file are deliberate, and we're good to go. This saved our first migration to disk, and now we can apply it to our instance. So if you now use a version control system for your code, you can store those migrations, and other team members having their own database instances during testing can actually now stay in sync, right? Same with rolling out a production database to a newer version. All right, so let's take a look around. To avoid having to type the module namespace all the time, I'm typing set module commonplace. EdgeDB provides very rich introspection, so we can look at what our defined type looks like. Looks like there's some metadata provided automatically for us as well. The query language should feel familiar for you if you already did SQL. There's insert, there's select, there's some data filtering we can do as well. So for example, on a regular expression, I like this particular filter a lot. It's very flexible. For example, having users ending with A, okay, cool. But we can also do something more flexible, like delete all users that have usernames that are 4 characters long, all right, okay. So that delete query already deleted 2 users, leaving just 1. So this sort of thing, right? Nothing magical, nothing unnatural, and that is the point. Now, all this querying reminds me that it will probably be a wise idea to make our usernames unique and to add an index as well, right here in line 6, to future-proof our queries in terms of performance. So we're doing this just now. Now the database is out of sync with the file that we just made. So we're going back to our command line tool, create another migration, and we can see that, it already understood that something changed, right? We altered an object. Let's actually look at this. We can see what the file looks like. That is going to be using the DDL language that is similar to, how SQL DDL looks like. So we recognize that, oh, there is an index created on our type, and there's also a property alteration that is creating a constraint, which is a standard exclusive constraint. Okay, great. That means we understood each other pretty well. So now let's apply the migration to our database. Migrate, and we are ready to go. your schema can have many modules. For example, we can create a utility module. That way you can version unrelated functionality separately and reuse it between projects. Here we defined a type that is a constrained version of a string that works well with URLs, right? So it's going to be like a slug. That is a term used widely by Django and other desktop publishing. So I guess it's not very different. And now we can change the type of name to actually be a util :slug. And again, do the migration dance to store a migration and to bring our database to our state. The point of our app, though, is to serve content, right? Not to just store users. So that content will also have a name, and we also would want to have the exact same properties as the name with user. So instead of copying and pasting, let's create an abstract type that holds this trait of what it means to be named. And now both our types can extend that named and as such reuse this functionality. I find this very elegant because now we can build other functionality using that same idiom. So there's going to be a bunch of other traits like titled, which is an optional property now. Like you can have a content title, or maybe it's just a stream of consciousness style sentence or whatnot, like without a title. It's publishable, so maybe we want to publish it at some date and only keep it alive until some other date. But for sure, we want to have soft deletes and decide whether this is visible on the website or not. Of course, we've seen already on the screenshot of the applications that we want tags. So tags, we're going to have to define those as well. But now the point being, we can just list all those traits on our content type. And now we know what that type is exactly without having a clutter of very, very many properties kind of clouding the big picture. I find this is a very nice compositional tool for complex schemas. So a tag, as we've seen on the other side, is another utility string with a regular expression constraint. We are not going to be using the actual hashtag character in our database. It's just a waste of a byte. But we're going to be using a very limited character set so that we understand each other very well on what it means to be a tag. So the last thing that we need to do here is to build two concrete kinds of content that we want to support. Let's say it will be textual content, right? So it's a note and an image. That image is going to store some bytes, right? So of course, for high traffic scenarios, you might probably want to store binary blobs in some other manner like S3. But for our small example, actually, this is convenient to just store everything in one place. We can finally return to Python. As you've seen already, connecting to an EdgeDB instance is simply a matter of knowing the name of the instance. So let's create a config entry just for that. The actual credentials are stored for you on the file system, so we don't have to worry about any secrets here. We don't have to worry about those secrets being now leaked to logs or any other manner. Like that is a pretty elegant way to deal with this. If you'd rather use a full-blown data source name URL, that is also a possibility, so don't worry about that. But here we are going to be using what is the easiest. Now we are ready to set up our database connections. Since AsyncIO applications are single-threaded, it's easiest for us to use a global connection pool. It will be initialized during a startup event of Starlette and closed during an equivalent event called shutdown. So here we're just assigning our created asynchronous pool to the global DB pool. We're creating it based on our DB instance, saying the minimal size is 1, maximal size is 16, and the shutdown simply closes that, so awaits on the db pool.aclose. Now, in all other Starlette lifecycle methods, we can just assume that dbpool exists and we can just use it to query the database without any more shenanigans. Like, thanks to it being a pool, it's already concurrent. That is a very, very convenient way to deal with this. To see the events in action, let's configure logging for our application. Thanks to this, we can output messages during both events to let us know what happened. So a little bit of configuration here using our debug toggle. And now we can log that, oh, we created the connection pool to EdgeDB. Same, we will say that we closed the connection pool when we are shutting down. Okay, cool. Let's see how that looks like. But before we do this, we need to set up some Python logging boilerplate. That is the standard logging any file format. Not much to see here. The only interesting bit is that we are still using UVcorn's default formatter, which is nice because it colors output. We have to actually give it that because otherwise UVcorn would just ignore everything that we are logging from our application. But now when we run UVcorn using our logging.ini, we see our message, created the connection pool to EdgeDB, closed the connection pool to EdgeDB. It works. This took us a while, but we are finally ready to get to the climax of today's episode, displaying data from the database. We'll start by displaying the tags. So we'll add content later. Now we are querying the database, selecting distinct tags from content. This is already an interesting query because if you think about this, tags were never an object in the schema. They are not directly available anywhere to query. They are just a field on other pieces of content. And those pieces of content are polymorphic. They can be either notes or images, but we can here query them in a very elegant manner, saying, hey, just gather all those and give me distinct ones. That is very useful for our purpose. Let's see how that looks like. Oh, all right, like we are actually getting somewhere. There's a bunch of tags on the left already. But wait, like, how come do they have nice icons? Like, I like those, but where did they come from? And where did the actual tags come from as well? Like, did we put the data there at some point? Like, yes, like I did. Kind of behind your back, I did a little of work that I'm gonna show for you right now. So first, the icons. When displaying tags, I'm using an icon class method that translates the text of the tag into a CSS class with a nice icon. They come from Unicons, which is a wonderful Apache licensed library of icons available on the internet. So I put the icon class in the globals of templates and a bunch of other convenience methods there. I created this to not waste time explaining you how to actually get an English time delta description. It is a file that contains a lot of this sort of thing, including the icon class, and the icon classes are here. You can see the mapping between the names of tags that I, as a content creator, would want to use to the icons that the Unicons creators created. So yeah, like those convenience functions that I put there, they're also on GitHub, as I told you. So if you are very interested in how you know, some of those almost one-liners work, like, go right ahead. So now I generated data using a streaming response and another two pieces of convenience methods. They are here, and we're going to be looking at the drop test data first. So there are a few interesting bits about this particular piece of code. So first of all, looking at the query to EdgeDB, you can see that it allows for polymorphic type introspection. So I was able to clear the database without spelling out any concrete type name. I just said, hey, any type that belongs to our module, let's clean those up. Since some data might still be used by other objects, we can sometimes receive a constraint violation error if we delete it in the wrong order. But for this particular example, instead of implementing a topological sort, I just retry, as long as there's something else to delete, eventually the ordering will become okay. This is not a production method, we are fine with its abysmal performance in this particular case. And finally, and probably most interestingly, this is an asynchronous generator. Why? Well, because I want to log messages when things are happening so that I can stream them as they happen to the browser. In fact, the makeTestData function looks very similarly to what we've just done. So as you see, there's tags that you've seen on the left, there's yields again, and there's queries to insert users, and then a query to insert actual pieces of content, right? So that is using, our schema and a bunch of variables from code that, just is a little bit long because it shakes up the randomization in ways that just look nice. But the actual query is essentially most of the logic here in this particular place. So now, here's how this looks in use. Of course, just relying on a debug switch is generally unsafe, right? Like in a production application, you'd want to additionally secure such an endpoint behind authentication, right? Otherwise, some random users would just clear your database. So don't blindly copy what I just showed you here. This is for our kind of exploratory purpose. Like the streaming response that you've seen pass by here is itself pretty interesting. So that particular method is nice. We can use asynchronous generators for that. In any case, we're ready to finally watch some content render. Let's see through some final changes to our code. So I've already made those changes to not bore you to death with my clumsy typing. So first of all, on line 52, you're seeing that we are taking tags given by the user in HTTP GET parameters. And we are using those query tags to filter content when querying the database. So that filter happens on line 54. We also make a generator expression called tags with availability, which allows the template to know whether there's more content under a given tag or not. And it will be either available for clicking or unavailable for clicking. So Starlette is already plenty performant, and our application, thanks to the use of async functions across the board, is pretty scalable as is. And if you need more scalability, you can always just run multiple UV corns with our app. All the data is safely stored in EdgeDB, which is behind you, so all's good. But if you'd further want to increase the concurrency of this particular endpoint, you can wrap the two queries that we have, line 54 and 55, in an AsyncIO gather so that they execute in parallel. Just be aware that the flip side is bigger load on the database connection pool. Now you're going to be using two connections concurrently to render this single homepage. So what's up with this hidden content query function? The tags query I just show you directly, but the query content is not here. Let's look at the code of that. So most of our function is indeed HQL. We're seeing a few interesting bits of the query language, in fact. First, we are not selecting a straight subset of some table like in Postgres, but with select in EdgeDB, we are constructing a shape whose matching members will be returned to us, but they might not actually be on the object itself, which we are querying. In this case, the shape includes a computable property called TS, and that isn't a field on content. That is just a result of some computation. In our case, that computation is simply this. If the piece of content contains public underscore since, use that. Otherwise, put the current server timestamp in. We believe this form of querying databases works better than typical object relational mappers, as it's both more performant and more flexible. You can construct shapes that respond to the particular need in a particular endpoint, right? So any query might respond with a much different shape. Note that to help static typing here, I needed to tell it what fields are going to be available in the resulting object. So to do this, now manually I defined a protocol on the top of the screen so that the type checkers know that the result of our function is going to be a sequence of some objects that contain the fields I specified. But if you think about this, this is in fact duck typing. I never told it what kind of sequence that is, and I never told it that it's going to be some content item class. I just specified it's some protocol, so it's any object that contains those fields. So we are using objects returned by the efficient database driver directly, and that makes it very performant. There is no conversion there at all. So now, sure, the way in which I had to concatenate here a little is maybe a little clumsy, right? The strings that I'm concatenating in this particular case might have been constructed by a query builder. And EdgeDB will provide a query builder for Python in the near future, but now the string concatenation is a small price to pay for performance that runs circles around object relational mappers. So here's our end result. Content that can be arbitrarily filtered. We can see like plenty of it randomly specified. We can specify multiple tags at once. If there's no more content, we cannot really click on those gray tags, but we can click on the blue ones, and that way actually drill down to the particular content we want. I have to say that it's pretty fun clicking through all those filters to just, find the exact piece that you're looking for. So I hope you enjoyed this end-to-end example of how Starlette can be used to build web applications and how EdgeDB powers this use case. We really do hope that it will transform how backend applications are written in the next few years. Importantly, EdgeDB technology is something that you are already using. The people behind it brought you async and await in Python. They created UV loop and async PG, the fastest Postgres driver out there, and even the syntax highlighter for Python that you're using on GitHub and Visual Studio Code, including in this talk. So most importantly, the core product is itself a Python 3.9 application right now. It is using AsyncIO and it is highly performant and scales very well. All right, so what happens next? That is for today's episode. I hope you liked it. AsyncIO is useful for much more than just plain networking. So in fact, it's used by Black to handle parallel formatting of many files. Those are CPU intensive blocking operations. So how does AsyncIO allow it? We'll be covering that next. Subscribe to make sure you'll get notified when the episode is out. Thanks for watching. See you next time.